Malaysian 370, contact Ho Chi Minh 120.9. Good night.
Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
From the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds."
Welcome, everybody, to the stream. I hope you guys are having a great Friday. I'm your host, Ashton Forbes. Today is Free Energy Friday. Welcome, everybody who's already in the stream. Man, we had some major streams this week. Guys, if you did not watch Monday, Tuesday, and Wednesday, strongly recommend checking them out. I'm pretty sure Monday we talked about Lou Elizondo, a little bit of the follow-up of the Candace interview that should be dropping in like a week or so. I don't really know when, just because she got banned off YouTube. We'll see. Tuesday, we had a special stream because we had a Navy SEAL come out and say that MH370 was a warning to China. That was crazy. And then Wednesday, we talked about secret science. I don't really remember off the top of my head what we talked about, but it was awesome, guys. So today, Free Energy Friday, we've got a major stream for you guys tonight. Tonight, we are going to learn how to do free energy. We're going to learn how to do free energy. You heard me right. So I have told you guys that one of the secrets is keeping your dipole open. Your battery. Keep your battery open. Don't break your dipole. Keep your asymmetry of charges. You have more negative charges on the bottom than you have on the top. This allows your circuit to flow. This allows energy to cohere out of the ether. That's all we have to do. And the analogy I give people is when you're pushing on a swing, don't push the whole time. It's counterproductive. Just push when the swing comes back in an oscillation. Well, today what we're going to learn is that you can push like that, and not only does it keep the swing going, it increases the amount of energy. When you push at the right frequency, you actually increase the amount of energy. Every cycle, the energy increases more and more and more. If you were looking at the thumbnail, that's what you're seeing in the thumbnail. So that's a little spoiler, guys, for that. Before we get to that, we're going to take a look at Hal Puthoff is going to explain zero-point energy because it's very important to understand where's this energy coming from. If that's possible, where's the energy coming from? It's coming from the zero-point fluctuations that are proven to be real from quantum mechanics. And then after that, I'm going to explain plasma. We're going to look at the video of the plasma that I posted like yesterday. And then I'm going to show how plasma can be a circuit. And then we'll look at the oscillations video. And then we're going to come back and look and see how oscillations can explain how we can do the same effect in a plasma as opposed to an electrical circuit. So we've got a lot of awesome stuff tonight, guys. I hope you're excited. It's going to be sweet. It's very moist tonight, guys. Very moist, just as Ellen says. Okay. So this is going to be awesome. So let's start with, and actually right before I show this, I'm going to show a video that's from Dr. Stephen Greer on one of his archives with Hal Puthoff. It's about 15 minutes long. We're going to listen to the whole thing. And I was just watching a clip on Twitter a second ago where Stephen Greer is saying that he was protected by somebody in the CIA who's like a really, really big wig in the CIA. It has to be Ron Pandolfi. He's the only one. If anything happens to me, the first person that should be questioned and the first finger that should get pointed is at Ron Pandolfi. Everybody that I've talked to says this guy's bad news. But somehow he's talking to Stephen Greer, and he was telling Stephen Greer that the Stars Academy people don't know what they're talking about, or something like that, which Hal Puthoff was on that. So I don't know what's going on with all these factions. I'm not on anybody's side, but I definitely don't trust the CIA. I definitely don't trust them. The only person that I trust that I've never actually talked to is Hal Puthoff. I know Hal Puthoff knows how this all works. I know he does. I mean, just listen to this video we're about to play, and then you're going to be sure too. Okay? Here we go, guys. White boy summer. Oh, snap. Summer's almost over, everybody. Summer's almost over, chat. Yeah, really happy to see all you guys in the stream so early as well. It's pretty awesome. Okay, so this is called Hidden Energy with Dr. Hal Puthoff, and this is by Dr. Stephen Greer. I don't think Greer is not Intel. Greer is definitely not Intel, guys. Greer ain't Intel. He's just he may have been misled a little bit, but this is what they do. Like, they mislead you on some of this stuff, and I think they turn people against each other as well, which is why I try not to be too adversarial towards anybody. It's not personal at all. It's not personal with Lou Elizondo. It's not personal with Jeremy Corbell, even though he like literally blocked me from going on Rogan. It's not personal with any of these dudes. It's not personal with anyone in the UFO community as well. I just don't trust them. That's all. Okay. Little free advertisement. I think this is Dr. Greer's thing. So he's never actually copyright striked me. So pretty sweet.
One of the discoveries that emerged out of modern quantum theory is that so-called empty space isn't really empty at all. It's actually full of energy. So instead of being like kind of a quiet, empty lake, it's more like the froth at the base of a waterfall or something. And this energy is basically electromagnetic in nature, and the energy density is quite high.
So right off the bat, he's already saying every single thing that I've been saying. And that makes sense, because a lot of the science I've been looking into is either literally Hal Puthoff or stuff that has been referenced in relation to his scientific studies. So empty space is not empty. The energy density in empty space is really large. And he's going to explain, how is this possible? Why don't we feel it? We do feel it. But he's going to give a great analogy where he's going to say, if you're in a tub and your body temperature is the same temperature as the temperature in the tub, you don't feel it. This is the same situation with the 0 point energy all around us. We're in an equilibrium state with the 0 point energy. But you would still be able to freeze the water in the tub if you cooled it down. If you took all the energy out of it, the water would freeze. Same concept.
In fact, it's so high that when it was first discovered mathematically, it was thought to be some kind of artifact of the mathematics. But then as time went on, there were even Nobel Prize winning experiments that showed that this energy in so-called empty space was really there. We don't usually notice it because it's so homogeneously distributed. It'd sort of be like sitting in a bathtub with at exactly your body temperature. You might not notice the water. But under certain circumstances, it can be disturbed or perturbed, and then it has effects. As I mentioned, some effects on atomic emission, for example, is what eventually ended up in a Nobel Prize for Willis Lamb of Yale University, and it's called the Lamb shift. And this is a recognition that, in fact, this energy disturbs atoms. So atoms aren't sitting in a void, they're sitting in the sea of energy. So once quantum theorists realized that energy was...
So right there, he references the Lamb shift. And the Lamb shift proves that the atoms are not in empty space. They're sitting in an equilibrium. Remember, on Wednesday, that's what we were listening. We listened to Thorsten Ludwig on Wednesday explain 0 point energy. So that's why Lamb shift is important. And then he's going to explain, well, what about the Casimir effect? And the Casimir effect shows that we can actually extract the energy and turn it into usable work. And then in 1984, Robert Forward, who's the other person that I've been referencing, if you've been watching my content, proved or showed scientifically how we can actually use the Casimir effect to extract 0 point energy to produce work. And that doesn't mean that's the only way. That just means that it is possible. And that's a huge realization.
There, the next question was, well, is there any way to tap it? And it was thought originally that probably not. It might be like trying to tap the heat energy around us. And you can quickly prove for thermodynamic reasons that it'll take more energy to tap it than you'd get out of it, so you don't come out ahead. But back in about 1984, a researcher at Hughes Laboratory by the name of Robert Forward showed that there was a particular effect called the Casimir effect, which demonstrated that in fact this energy could be tapped. Well, when you go to look at the numbers, you find out that there's enough energy in the volume of a coffee cup to, say, evaporate all the world's oceans if you could.
So Hal Puthoff has mentioned this several times. There's enough energy in a coffee cup, or let's say this cup of, let's call, oh, you guys saw the brand, this can here, to evaporate all the Earth's oceans. This is first credited to Richard Feynman and John Archibald Wheeler. Richard Feynman of the Manhattan Project, extremely famous physicist, said that there's enough energy in the area of just a coffee cup, or, you know, whatever, the small area, to vaporize all the Earth's oceans. Basically infinite energy. Infinite energy. And that's who Hal Puthoff's mentioning here. For some reason, the volume does not go higher. He's just speaking very quietly, so I apologize. I can't turn the volume up.
Get it all of it. So this raised the issue among theorists. Well, can we manipulate this energy? Could we tap it for spaceflight application, for example? And there are a couple ways to go. Could we get propulsion out of it? Could we use it as an energy source? And so these are the areas that modern theorists are looking at. But one of the more interesting aspects is that if in fact it does look like there's a route from here to there, then, you know, we consider the possibility that, well, maybe there are other civilizations who've been down this track ahead of us. And so it opens up the possibility that you can't reject the possibility of, for example, ET visitation out of hand. Usually here, where Einstein said you can't go faster than the speed of light. Well, that's something out of special theory of relativity, and it really is that you can't take an object and speed it up and then through the light barrier, because it would take an infinite amount of energy and mass to do it. But it turns out it's a faulty conclusion to say, therefore, you can't go faster than the speed of light, because once you get into general relativity, you have some options. The options are to change the properties of space itself, so that locally the velocity of light is engineered to be faster than the usual value.
My God, I love Hal Puthoff. So first of all, this guy's seen some alien UFOs. If aliens exist, this guy's seen the UFOs. 100%, no doubt whatsoever, he's seen them. He's just cold-blooded, man. He's cold-blooded. Like, he doesn't, like, he's got the best poker face. He doesn't give anything away. He just stays perfectly neutral all the time, which is exactly what you want. And you can just tell he's speaking the absolute truth here. And then he says, well, Einstein's general relativity. Well, first of all, he says that if there are alien civilizations, you can imagine they've already figured this out, which that's his little nod where he's saying, like, if there's UFOs flying around out there, like, we know they're using this because we saw them floating around and we were like, how are they doing that? And we figured it out. And then he says, Einstein's general relativity would say that your object, like my headphones here, I can't push this to the speed of light. And we definitely can't go faster than the speed of light, but you can't even go to the speed of light because the faster I push this, the more energy it takes to increase the acceleration. But he says, that's not the way to think about it. The way to think about it is you want to manipulate the area around your object, manipulate the permittivity of free space itself. When you manipulate the permittivity of free space, you change the refractive index. Changing the refractive index changes the speed of light. And that's why he's saying if you manipulate the medium, you can increase the speed of light itself, and now your object can achieve what we would call superluminal speeds. Pretty incredible.
The best way to explain how it is, how it comes about, is that it's actually the idea of stretching space, expanding space on one side of the craft and shrinking space on the other, so that you're not only moving forward through space, If the space itself is like moving forward on a rubber sheet, while at the same time you're pulling the rubber sheet and expanding it, so then relative to the outside environment, you can be going at, say, the speed of light along the rubber sheet, but if the rubber sheet itself is moving relative to the rest of the universe, then your net motion is faster than the speed of light. So the implication then is, well, if you can manipulate this zero-point energy C, get it out of the way, then if something tried to accelerate you, it would be easy. You would.
So right there, right? He explains Alcubierre warp drive. So says Alcubierre warp drive, and then he just gives away the bingo, the Yahtzee moment. It says remove the 0-point energy in front of you. And then what would happen? Now you've increased your speed of light to infinite. And now it just takes a little bit of a push and you poof. You go warp speed. You go teleportation speed. You go, I don't know. We don't know what the limit is. Practically nothing. No limit.
Have no, quote, inertia. It'd be, rather than using humongous amounts of energy to try to propel you through this tremendous force drag that you get from the vacuum fluctuations, you could throw BBs out the back, I suppose, and take off like a shot. And so, in fact, the Air Force was sufficiently interested in that they set up a program called mass modification, in which I and my colleagues were interviewed to find out all the details of our modeling inertia as a vacuum fluctuation phenomena that might in principle be manipulated, to see if there was a possibility in some far distant future of reducing the inertia of a spaceship so that ordinary propulsive means could be used with relatively low energy requirements. And so they did a year-long study and went around to various universities and laboratories and asked people to tell them about experiments they might be able to do to determine whether our model was correct. So again, there's another indication that these are not just fringe scientists with science fiction ideas, but that basically these are kind of mainstream ideas being published in mainstream physics journals and being taken seriously by mainstream military and NASA type funders.
How sad is it that Hal Puthoff's like in his 80s? So nowadays, there's people like me and you all guys who are like, yeah, we can actually wrap our brain around this. But even now, you guys see how much resistance there is from academia and the skeptic community where they think this is all pseudoscience because they don't understand anything about physics, unfortunately. So only now, potentially in 2024, are we even ready to accept this? Hal Puthoff's been living his whole life where he knows the answers to this stuff. He knows it's real. And he's got idiots just out there being like, this isn't real. I'm going to hit my club against the ground. This is just a magic firebox. Like just straight up caveman level ignorance, right? And Hal Puthoff's out here like, yeah, I've seen floaty orbs and UFOs and shit and probably has built the stuff so he knows it's legit. This is probably why he's so desensitized to it, where it's like how you'd ask yourself, like, if you know what this guy knows, how is it that like you just don't tell anybody? Because you just realize everybody's just a sheep at this point. It's just you have the elite people that understand that this is real, and then you just have the morons. And you're like, okay, if you want to be a moron, if you want to be a Mick West of the world, right, and have no concept of how warp drive is even possible and go out there and try to debunk other people and try to ridicule them, well, whatever. Like, he's going to cry himself to sleep in his bed of millions and millions and millions of dollars, right? So Hal Puthoff doesn't give a shit.
A whole volume of space would be in a special state. So the pilots, for example, would not feel inertial forces either. And so under those conditions of promoting a situation in which you get rapid inertia of a spaceship, the people inside would, under those same space manipulated conditions, not feel tremendous inertial forces. Here at the Institute for Advanced Studies, one of our main interests is...
Sorry to pause it, but there's one more thing here that's the issue, right? So here's a question. How do you alter the physical constants? This is kind of related, because some people would say, well, the speed of light's a constant. The speed of light's not a constant. That's the problem. So that's the issue. Speed of light is not constant. Speed of light is only constant through what we call a vacuum. But the moment you realize that the vacuum is not really a vacuum, that space isn't really empty, then it's the same issue as if I shine a laser through a cup of water, you're going to see it bend because that's the refractive index of the permittivity of the water. You can do the exact same thing with space. The only reason why we don't realize that is because we live in the medium. Since we're in the medium, we don't see outside of the medium. That doesn't mean it's not possible. But we know you can bend light. Why? Because we see gravitational lensing when we look out into the sky. We look into this space, we see gravitational lensing there before we know we can manipulate the medium. And then, especially because gravity itself is just an induced effect of the 0-point energy densities. This basically just solves general relativity for us. This unifies general relativity with the larger concepts. And I just forgot. Oh, the part that I'm concerned about is that if I would not want to be inside one of these crafts. It's not that I'm afraid of the inertia. Zero inertia is great. But what happens when you're experiencing no gravity? Not like literally outer space no gravity, but like no inertia whatsoever. You're going to have a time dilation effect. In my opinion, I don't want to get into a situation where my time is flowing differently than the outside, because I'm going to show up in the future. And for me, it's going to appear instantaneous. But all of a sudden, my biggest fear would be you go inside one of these crafts and you go to Alpha Centauri and then you come back. So a round trip, go to Alpha Centauri and come back on one of these crafts. For you, it's, let's say, instantaneous. But to make it simple, let's say it takes 1 day. 1 day. I go to Alpha Centauri, I come back 1 day. When I get back here, it's 100 years later. Or really what it would be 8 years later, let's say. 8 years later, because that's the speed of light in the vacuum. So you show up and you've now lost 8 years. And your family's like, you were gone for 8 years. You're like, no, I was gone for 1 day. Can you imagine how weird that would be? That's the problem if you're floating inside one of these crafts potentially. There's going to be a time dilation effect. I'm almost 100% sure.
Exploring the possibility of tapping or mining this vacuum fluctuation energy, 0-point energy. By the way, we call it 0 point because even if you froze the universe down all the way down to absolute zero, where most motion would be frozen out, this energy would still be there. It's a very fundamental kind of energy. But we're looking to see if we can extract it for many uses, not just spaceflight application. I mean, the grand outcome would be that if you could use it to power everything from electric toothbrushes to aircraft carriers to automobiles to homes to space flight. One of the main areas of interest, actually, in terms of potential use that we've been approached by many people, is the possibility of having a very cheap energy source for desalinization, which is very hard to make antimatter in large quantities and keep it bottled up. But it has been done. Antiprotons have been generated in accelerator experiments and then captured and kept contained for some periods of time. So that's an area that I know the Air Force has been interested in and pursues research on.
Desalinization is interesting, but guys, from what we've learned, if you guys watched the streams about exotic vacuum objects and plasmas, desalinization, okay, great. That's unlimited drinkable water. Okay, but we can literally just pull elements straight out of the vacuum, straight out of the 0-point energy fluctuations. Elements. We can actually transmute elements as well. So you get to the point where we can just pull hydrogen straight out of the vacuum. We can just make water if we need to. So at some point, you're going to find that scarcity immediately disappears. There's no scarcity anymore if you can just produce elements at will.
Sometime before this millennium is out, I'm certain that probably that will come to use if there aren't other alternatives that are simpler. I routinely make presentations and briefings to various branches of the government. I've been taken out on aircraft carriers by the Navy and shown what it is that we have to replace if we have new energy sources to provide new fuel methods. Of course, NASA is funding some of these breakthrough propulsion physics ideas. The Air Force, various labs in the Air Force are pursuing.
So he mentioned the NASA breakthrough physics propulsion study, which was from 1996 to 2002. Damn, guys, I'm getting good. Like, pretty soon I'm going to be able to like know Hal Puthoff's entire life and read his horoscope at this point. So this tells me this interview is probably mid 2000s, if I had to guess. I put the description. The link is in the description if you guys want it, by the way.
Fundamental studies on these kind of exotic ideas. So there's a lot of government interest. It's getting to the point where modern theoretical physicists are loath to rule out any possibility. I mean, now we're talking about parallel universes and membranes of many dimensions, and I mean, the physics is just getting as wild as it can possibly be. And sandwiched in among all those alternative possibilities is the possibility that some of these concepts might actually play a role in spaceflight application, where civilizations, ourselves in the future, or maybe more advanced ET civilizations at present, could perhaps travel long distances in relatively short times. Of course, we see claims, and not just among the public, but among military pilots and good observers, typically in the military, that there appear to be something like craft flying around with anomalous behavior. On the other hand, in terms of some of the characteristics that seem to be attributed to them, and giving the kind of physics and direction physics is going, you can't rule out that maybe some are some kind of craft or probes, maybe even more likely probes and craft from some faraway civilization. Of course, one of the intriguing things as we start looking into the possibility of reducing inertia and so on, and then you see these supposed sightings in the sky which turn on a dime, right angle turn, and so on. And the reason we used to reject those out of hand was that it appeared to be there was no inertia there. And until recently, that was sort of an inconceivable idea to a physicist.
So one more thing I want to bring up here, guys. This is a unique thought. I see a lot of these things, these time frames in the UFO community. Well, since we know how time dilation could work, what if we were told, like, imagine a civilization came here and they said, we're coming from Zeta Reticuli, which is 40 light years away. So we know there's going to be 40 years of time dilation, 80 years on a forward and back trip. For them, it may be instantaneous, but for the time dilation effect, you could have 80 years go by. What if they came here 80 years ago and they said, we'll be back. We're going to go back to our home planet and we're going to come back with an army and we're going to invade you? That would be scary, because then you would have a clock. You would know exactly when they're going to come back. For them, it might seem instantaneous, but they would show up 80 years in the future. And we would be able to basically mark on our calendar 80 years from, let's say, what's 80 years ago? 1945. Let's say we dropped a bomb on Hiroshima in 1945 and Nagasaki, and then the aliens say, we're going to come back in 80 years. We're going back to Zeta Reticuli, and then we'll be back, and then we're going to wipe you out. And the aliens come back now in 2025, 2027, whatever the year is, right? And we know they're going to come back, and we know exactly when they're going to show back up, because we know we can calculate the time dilation effect. In the meantime, we're just sitting here with our dicks in our hands like, yep, it's going to happen at some point. And then you kind of wonder, like, maybe we calculated wrong. Maybe they just don't come back, right? Maybe they went back to their home and they're like, they just changed their minds, you know? Pretty scary to think about those kinds of thoughts. But you kind of have to think about them with respect when you start talking about time. And then with respect to what other people said, yeah, we can prepare to wreck them. This is what I was going to take to the next level. Is that somebody said, do you think that they won't attack us, or that there will be no attacking if like we know we have this technology? Kind of depends. I think that this is why Russia and China aren't going to mess with us anytime soon. But I do agree that Russia and China are probably trying to catch up. I think China is going to catch up before Russia will, just because they're more industrious. And then it's a matter of who has the highest advanced level of this technology. Now, if you guys watch the three-body problem, in the three-body problem, it was like we are just figuring it out, and then the aliens that are coming here, they're like way up here, like way, way, way more advanced than we are. But you can close the gap. That's why I say that no matter if aliens exist or if they're good or bad or whatever, if we got this technology from them, we have to reverse engineer it. Doesn't matter if they're benevolent, malevolent, or neutral. The outcome is the same. You need to reverse engineer it. You need to try to close the gap and catch up. The same way that China is trying to catch up to us right now on this. And then somebody else said something about parallel universes. I mean, that's what Hal Puthoff just said. Like, now you start bringing up the question of like, if you go through a wormhole, are you going to a different unit? Like, are you going to a different timeline, or are you still in this timeline still? And how does that all work? I mean, to me, you can only speculate. No one can say, I know for sure you're going to another timeline, because without experimenting, you just can't be sure. It's too far out there in terms of the concepts. But have fun speculating.
I think physicists is probably pretty justified in saying, that doesn't sound like anything I can imagine to be a craft. Could imagine it to be some form of plasma phenomena or whatever, but not a craft.
Did he just say plasma phenomenon, chat? Did he just say plasma phenomenon? And I'm sorry for the static. I think that's just the recording. Holy shit, did he just say plasma phenomenon?
Say, that doesn't sound like anything I can imagine to be a craft. Could imagine it to be some form of plasma phenomena or whatever, but not a craft. And so now, as we get this new evidence that, well, okay, maybe inertia can be modified, then it does make you sort of sit back and take a second thought about it. But when you consider that our electromagnetic technology is, a century old, basically, and then realize that you could have advanced civilizations out there that are millennia beyond us, there really is no way of saying whether they might have some other way of making contact, or find other ways like wormholes of just sending probes here, or whatever.
Or whatever. Like, I mean, hey, man, they might just be plasma orbs, and they might just be able to make wormholes, man, or whatever. It's like, dude, this dude knows. This dude knows, man. He's not speculating here. He's not speculating. Dude, Hal Puthoff is just a G, man. Cold-blooded. Like, yep, the aliens might be visiting here. There might be plasma orbs, and might be able to make a wormhole as well. Like, are you kidding me, Hal Puthoff? What have you seen, my man? What have you seen? And for the record, I still do not believe this is aliens that we're looking at in this video here. I absolutely believe these are our orbs, 100%. And I believe we're controlling them autonomously through AI or something like that, or some kind of advanced supercomputer. But come on, man.
Well beyond our imagination.
It's not even imagination. He's not even speculating.
They might have some other way of making contact, or find other ways like wormholes of just sending probes here, or whatever. It could be well beyond our imagination. The case that NORAD has uncorrelated targets that they can't account for. And from time to time, satellites see things called fast walkers. Seem to be energetic signatures moving faster than can be accounted for by known planes.
Are you kidding me? Dude, come on. Of course the videos are real. Come on, bro. Fast walkers seen by satellites moving in ways that planes can't tell? Bro, this is the Sibber system. We're looking at the fucking Sibber system right here. That's that cursor coming on the screen is somebody literally operating the system. That's your fast walker right there. You just saw it come flying in right here, chat. You want to see a fast walker, guys? You're looking at classified fucking satellite imagery right here. That's a fast walker. In fact, in this case, it's probably just us. But imagine if you are an analyst, right? And you're looking at this, you don't know this is us. There's nothing on here that says this is us. In fact, you're immediately going to assume it's aliens. If you're looking at the Sibber system and you're an analyst and you see this shit, you're going to go, okay, there's fucking aliens. Aliens are here. Aliens are visiting us. Aliens just warped that plane away, right? That's what you're going to think watching this. Especially if you don't understand the science. If you haven't watched all Hal Puthoff stuff, if you haven't watched my content, if you haven't looked at the plasma, of course that you're going to think it's aliens. Look at this shit. You're like, okay, is somebody playing a prank on me? Because these orbs are spinning around this plane now, and it's clear that they're intelligently controlled. Clear, right? The way they're moving is intelligent control. Now you could say it's a computer or AI, but that's still intelligently controlled. Absolutely. And then they just, and now they're changing, and then poof. And then now this is the part where you freak out. Like if you're this NSA person or whatever watching this, and NSA is the ones who manage this most likely, along with the NGA and the NRO, you're watching this. This is where you are like, and this is probably what happened to Edward C. Lynn. Or if somehow it was somebody else that leaked these videos, they freaked out. They freaked the fuck out. Because they would have had no idea how the physics works. They're just like doesn't matter what your rank is. You're not a PhD physicist. So you're going to look at this and you're going to think like, okay, aliens just warped the plane away. That just went to the Xenu dimension. It's gone now. So of course they leaked the videos. Of course they leaked them. They thought aliens zapped the plane away. They were like, well, this is disclosure. This is true disclosure right here.
People of some...
I'm going to replay that.
And from time to time, satellites see things called fast walkers. Seem to be energetic signatures moving faster than can be accounted for by known planes, for example.
But guys, he's seen satellite videos. Like, you don't say that unless you've seen this. Unless you've seen this. And they were like, hey, Hal Puthoff, you're on the bigot list. Like, we're gonna show you this footage. You need to tell us what the fuck we're looking at right now. And then Hal Puthoff comes in and says, yeah, that's like a plasma orb, and it's, just manipulating inertia through 0-point energy fluctuations. Like, this is, my God, man. My God.
People of some credibility and credentialing are willing to come forth and say, despite the giggle factor for this area, we think there's something there that should be taken more seriously. Well, it's another mark that kind of an idea whose time has come to take.
He just mentioned the giggle factor. So somebody just literally today told me that Eric Davis posted a paper about the giggle factor in UFOlogy, that mainstream physicists giggle at this stuff because their brains like literally fry when they think about it. They can't even conceive it to be real. They call it the giggle factor. I read it earlier today. Now he's referencing it right now. Chat, this is getting weird. Also, there was this woman earlier, like yesterday or 2 days ago, where she's another whistleblower, and she worked with the NGA, I think, the National Geospatial Agency. And she was saying that she saw stuff that you can't explain by human means. This is the misinformation. This is how people like Lou Elizondo, Jeremy Corbell, George Knapp's, even Ross Coulhart's, they are pushing this idea that it must be aliens because they don't understand physics. This is why everybody's saying it's alien. This is how we're being misled by the UFO community, because these people don't understand physics. And when you don't understand physics, you look at that. And if you're like an analyst, like that lady is, you go, this has got to be aliens. You don't realize that, no, Lockheed Martin can engineer that because they hire Hal Puthoff, who knows how it works. Doesn't mean the aliens aren't real. Just means that when you're seeing weird shit that's defying gravity, it doesn't mean it's automatically aliens. This is the number one fallacy that I see UFO people fall into, is they go, we can't possibly understand that, therefore it must be aliens. No, what you mean is you don't understand it, and you haven't tried to understand it. I've looked into it, and the papers are all out there, and they go back to the 80s at a minimum. They at least go back 45 years. They might go way further back than that as well. So to claim that we can't have figured this out is nonsense, complete nonsense.
Seriously, it should not be an area considered taboo.
Okay, I want to address this question. Thank you for the donation, Chameleon UK. Welcome. I don't recognize your name, but if you've been here, I appreciate you. Do you think somebody asked Lynn to search for MH370, or do you think he just stumbled onto the video? That's a tough question. And of course, this is speculative. Let me go full screen for a second. But I would say that, remember, the French father was told by an intelligence source that the Americans know what happened to the plane and that there was 2 AWACS in the area, which are spy planes. Edward C. Lynn flew in one of those spy planes. I would almost guarantee he was there that night when it happened. He was there that night. He was possibly part of the operation. He might not have been read into what was going on with this operation. So I think that he saw it in real time, freaked out, had access to the videos, and then he showed somebody else right away. He said, maybe he went to one of his friends and he was like, you're not going to believe this shit, but that plane that disappeared that everybody's looking for, yeah, I've got the videos. I know what happened. And then he sends them to him. The moment he sent them to him, biggest mistake of his life. Because then what does that person do when they get those videos? They put them on the internet. They go, holy shit, I'm going to put these on the internet because this is too crazy. This is like catastrophic disclosure. And they probably thought this is aliens because they had no idea. Maybe Edward C. Lynn didn't even have any idea. He could have even been told that we were doing an operation, and then he sees that shit happen, and he thinks, okay, aliens just teleported away a plane that was on fire. Right? Seems reasonable. But truthfully, we can't know for sure. How do I go back?
By modern scientists. Here you have a guy who shows up before congressional committees doing whistleblowing activities, and under circumstances where a lot of people, if they could find holes in his credibility, would have been more than glad to try to destroy his stories and his credibility, and they didn't. And so then you suddenly have a fellow like that coming forward and saying that he has evidence from his own experience that there was crash retrievals and technologies that he personally was involved in distributing out. Why would a guy with that kind of background make it up? I had a chance to ask him about it once. And he said, well, the way it came out in the book is not exactly the way it was, but it's really that we waited until there were developments in regular American industry. And then we would salt stuff in that might accelerate those developments. It isn't that the developments got started on the basis of what we had because we didn't want anybody to know we had it. You can't.
Did you just hear what he just said? He said, we don't necessarily leak the technology, but we wait for the natural development of the technology, and then we kind of give it a little boost. We give it a little boost. We push it forward a little bit. Why? Because we don't want to reveal that we've already figured that technology out. Holy shit. Holy shit. I mean, it all falls into place. The whole story falls into place here. Hal Puthoff has seen it. We've figured out plasma orbs. We've probably figured it out for a while. We are seeing the stuff fly around. The reason why we don't have our whistleblowers coming out is because the government knows that at least some of them, if not all of them, are us. And that the people that are seeing it in the satellite videos, they don't even know that it's us because it's third-party defense contractors, and the people that work for the NGA and NRO are government employees that have no idea. So some lady sees it on there and she starts going, well, I saw this aliens, and they go, well, you have an NDA and we can't tell you anything more about it. So the lady immediately thinks, oh, I'm looking at aliens here without having any concept that we have figured this out for decades. Yeah, it's all coming together, chat. I'm going to play that one more time. I'm going to go back because that was crazy.
It's not exactly the way it was, but it's really that we waited until there were developments in regular American industry. And then we would salt stuff in that might accelerate those developments. It isn't that the developments got started on the basis of what we had because we didn't want anybody to know we had it. You can't probably dismiss it out of hand. because it's hard to come up with a reason why he would have just made it up, because he's a very sort of patriotic kind of guy. So yeah, that is really an enigma.
Man, that's wild. I want to see every video that includes Hal Puthoff. I want to see every single video. If you guys have more videos of Hal Puthoff that are out there, I feel like I've seen every single one. But if you've got more that are out there somewhere hidden, put it in our Discord, guys. I'm going to put a link to the Discord there. This guy, I know he knows. I know he knows. I'm a good poker player. I can tell this guy fucking knows. And I can read him like a book too. So I want every video that this guy has ever done that's out there in the public. Every single video. I can glean so much information off the stuff he says. Once you know somebody knows, it's really easy to glean information off of them because you can just tell he's telling the truth. Whoa, holy smokes, Devos. Wow, Devos. Wow. Thank you very much, sir. That's a very big donation. Very much appreciative. I haven't said this in a long time, but because I haven't had to. But yes, if you need your money, keep your money. I don't do this for the money. I could be monetizing way more. This isn't even my job, actually. I just do this because I love this. That's the only reason. In fact, I've been told by several people behind the scenes that I've done more than enough to push, let's say, disclosure forward. And I keep doing it anyway. Why? Because I just love this. I just love it. That's why. That's the only reason why I keep doing this. If I wanted to, I could step back. I could get away from all the toxicity and the fake shit people make up, but I just don't care. I don't care. I love it, chat. So thank you very much, Devos. That's awesome. And yeah, so I hope, I've kept my job this far, so it's pretty awesome. It's been tough, but it's been exhausting, guys. Yeah, the stuff is just fascinating. I mean, I didn't know plasma was the secret to all this stuff. I didn't realize how important plasma is. And the more I learn, the more I'm just like, wow, I want to know more. I want to know more. I want to know, like, how can we really push this to its limit? How can we push it to its limit? So the next thing I want to talk about, I want to show the video I did. I edited this video down from a longer video. Before you ask me, I don't even remember where I got it. Oh, I saw it on Reddit, actually. I saw it on Reddit. I don't really go on Reddit very much anymore, but I opened it up and this video was there and I was like, holy shit. Plasma in zero gravity in outer space. Maybe the best video I've ever shown. Because the big part of plasma is its natural ability to cohere into these shapes. This self-sustaining, self-organizing, the self-organizing mechanism. The fact that there's this self-organizing property really makes you wonder about consciousness. Like if things were just random and I threw some salt into the air, you should just expect it to just not form any type of coherent shapes. But instead, plasma forms these self-organizing shapes. And it makes you wonder about what the nature of the universe is. And is zero-point energy doing this? Like, what's going on with all of this? So watch this video. I added some cool music to the background. This one? I think this one. I mean, are you kidding me, chat? Look at this. Doesn't this look like the universe? Like when we look out there in the universe isn't this big, like this homogeneous sheet. You can imagine there's like little like tentacles basically of energy. You know, that's how I imagine it to form. I don't imagine it to be this flatness that's out there. And so when you look at this, it's just like, and it's going to get crazier, guys. Like, it feels like this can explain everything. Like this can explain the universe. This can explain dark energy and the way that galaxies form. This can even explain life itself. I love this music, by the way. So right there, if you didn't read the commentary, he's saying that basically electrostatics cause plasma to form these crystal lattice structures, which is why we're seeing this structure of the plasma. And you're seeing it up close right here. And then it does something really weird where you literally see what looks like a black hole. Looks like a black hole on a plasma scale. Get ready for it. That's a galaxy right there. And the best part is the reason why we think we need dark matter is because the edges of the galaxy spin faster than we would expect if there's not dark matter. So they added this idea of dark matter because they say, well, we have to be able to explain why is the edge of the galaxy spinning, the stars on the edge of the galaxy, why are they spinning so fast? Because the universe is electric and also plasma. And this is why. You can see it right there. You're looking at, if you were to scale that up, that's what a galaxy looks like. Wow. That's a double helix structure. That's DNA right there. They literally form a double helix structure. Yeah, exactly. DNA. I mean, how can you not notice it? What the F? I mean, look at that. If the plasma is cooled cryogenically, a DNA-like structure appears. I mean, shit, this, now you guys know why I clipped this. I mean, this should have millions of views, but instead there's like stupid TikTok videos of like girls dancing and like showing their butt, and that gets like 10 million views, or like two people fighting and beating the shit out of each other or something like that. But when you actually show people like, hey, the universe is electric and here's a plasma experiment in 0G that perfectly describes how galaxies formed, literally describes how life itself is formed in a double helix structure. People are like, what? I don't understand this. You can literally just see it with your eyes. There it is. Absolutely incredible, man. I'm going to post it on TikTok. You kidding me? I'm getting the credit. I'm going to start posting on TikTok, by the way. Ugh, makes me sick just to say that, but that's what we're doing. Okay. Now the next thing. So we looked at some crazy plasma, but why is it important? It's Free Energy Friday, okay? And we're going to get to the free energy video next, but before I do that, I want to read off something. I don't have a way to show this without showing my DMs. So I'm going to just have to read this off for you guys, okay? I'm going to read this off. Okay. So somebody created an AI that takes plasma, because they saw my plasma video and they were like, hey, I made this AI that like pulls all this plasma information together. Do you want to ask it anything? And I said, yes. I want to ask it about charged clusters in plasma. Actually, we're going to show one more video now that I said that.
Sun is plasma. Aurora borealis, the northern lights, is plasma. It's the fourth state of matter. It's what happens when the electrons and the neutrons become completely disassociated. Solid, liquid, gas, degrees of freedom between electrons and neutrons, right? Even in a gas, there's still bonds. But when you get to plasma, they completely break free. So now you have electrons, neutrons become ions, and because they're electrically charged, they can be influenced by magnetic fields. And they also have this tendency to self-organize under the right conditions. If you apply the right frequency, it's like they spontaneously organize into toroidal forms. And then what happens is that, if you look at a torus in cross-section, it looks like an infinity sign. Here's what you do. Visualize a sphere with a North Pole and a South Pole. And now let's say you collapse that sphere so that the North Pole and the South Pole meet at the equator. So now you've got this like indentation in the north and the south. What then happens is that you get this electron or ion or both stream starts spiraling down that funnel, and as it's spiraling down, it's increasing and increasing in rotational velocity. Now, in the northern hemisphere, say, it's going clockwise, and in the southern, it's going counterclockwise. And they meet at the equatorial plane. And that's where something really interesting happens that I don't understand. Something happens there that's almost
The thing that I think happens there, which I'm still trying to understand and figure out, is that I think it may be forming a magnetic monopole. It's basically tapping into the ether at that point of equilibrium, or that point where the electron-positron pairs are meeting there. I think that's what's happening. Is it's tapping into the ether. It's forming a magnetic monopole, potentially. And that's what we're seeing in the plasma orbs as well. So I asked the person that made the AI, I said, I want you to tell me about charge clusters in the plasma. Charge clusters in the plasma. Why? Because like Randall Carlson just said, and by the way, Randall Carlson and Mr. Wolf it looks like he's agreeing. So maybe I'm on to something because Mr. Wolf is very smart. You might maybe lose my train of thought. Oh, the letter to Ashton Forbes was not trying to get me to find Malcolm Bendel. It was not trying to get me to find Malcolm Bendel. It wanted me to find Randall Carlson. That's who it wanted me to find. And now I know why, because of that video right there. They wanted me to look into plasma. They wanted me to find out how the plasma orbs are working, because that's the secret. That's the secret sauce. The plasma can create this charge cluster, which can create an energy density that's so high that it can actually teleport an object, but it can also just be free energy. We don't need to make a tokamak, these donuts. We don't need to make a tokamak reactor. We can just have self-coherent, self-organizing plasma, magnetically confined, and that can produce free energy as well. A very simple monostructure, as the letter to Ashton Forbes would say. So I asked the person, what does your AI say about charge clusters? And I thought, well, if you haven't been following me, and I say this with Candace Owens, unless she edits it out, but I say that the secret to free energy is keeping your dipole open. Keep your dipole open. And then what I mean here is that you don't allow the battery, if you want to think of it, or a capacitor, to equalize. Don't allow it to equalize. You want an asymmetry. You want more negative charges on one area than the other. It doesn't have to be on the bottom or the top. It can just be anywhere. As long as there's more electrons in a charged dense cluster, you're going to have energy flowing. You just keep that going. And plasma is the perfect medium to pull that off. So what did the AI say? How electrons organize external electric fields. When an external electric field is applied to a plasma, it can create regions of charge separation. That's our asymmetry, causing electrons to organize into clusters. These clusters form where electric field is weakest, allowing for stable configurations. The magnetic field, if a magnetic field is applied to the plasma, electrons experience the Lorentz force, which organizes their motion into a spiral or circular paths, leading to self-organization into charge clusters, typically along the magnetic field lines. There you go. Now you understand why, when we just watched that video of Randall Carlson, why I think we're looking at a magnetic monopole. You're seeing the vortex action happen. Plasma naturally tends to be a quasi-neutral, meaning that the overall number of positive and negative charges balances out. Oh, sorry, the header here is asymmetry and free energy in plasma. However, under the right conditions, such as with an application of an asymmetric electric field, you can break this balance and induce charge separation. By doing so, you create regions where electrical potentials build up, and this potential difference can be exploited to extract energy. This is similar to how batteries work, except that the energy comes from the plasma interactions and the electromagnetic fields. By creating a controlled asymmetry where the electric field strength is greater in one area than the other, you can extract energy. Charge separation. When an asymmetry is in a charge is induced, it creates a potential difference. More over here than here, or vice versa. This difference can drive currents in the plasma. Current, just like when we have our battery connected to our circuit, it creates a current, which can in turn be harnessed to do work, essentially generating free energy from the movement of the charged particles. So the movement of the charged particles themselves in the plasma just causes free energy to just happen. We're straight out of the ether. Plasma oscillations. And this is going to lead us into our next thing. If asymmetry leads to plasma oscillations, these oscillations can be converted to usable energy through resonant electromagnetic fields. For example, by inducing Langmuir waves, oscillations of the electrons in an asymmetric plasma, the energy stored in these oscillations can be harvested. Woo, chat. Wow. Yeah, I even understand that, chat. Like we're starting to scare ourselves here, chat. We're scaring ourselves now. Why? Now let's take a look. Oh boy, you know what I'm about to bring up. Dun dun dun. Now let's skip ahead a little bit. We want to see the zoomed in video. In fact, I'm going to show this in slow-mo. Let me switch my view. I want to watch this in slow motion. Thankfully, there's no sound, so we don't care about the sound here. Let's go. We're going to go super slow-mo. I want to zoom in. Here we go. This video is proven fake by the Corridor crew, Ashton. Yeah, right. When the Corridor crew gets a PhD in quantum mechanics, then they can come back and try to debunk this video. Look at that heat signature in those orbs. Look at it spin around on its axis. You're seeing the vortex of the asymmetry. The reason why you have the heat difference there is because there's the asymmetry. We're staring at the asymmetry right here. You are literally staring at the asymmetry in the plasma. This is how they are cohering energy out of the vacuum. This is how they're doing it. You're looking at the asymmetry right there. You're staring at it. It's really only a matter of exactly how they're doing it is the only question in terms of like where's the exact points and the angles. Like we know exactly how this is working now from a physics perspective. It's a plasma and they're putting a current through it and they're putting a charge in it. And the fact that there's more charge in one point than the other creates your asymmetry. And now energy just straight up coheres. Permanent dipole. Absolutely incredible, chat. So let's figure out now. The next thing we're going to do is we are now going to watch this video on oscillations. I think I have it queued up somewhere. Yeah. Okay, this one's called Parametric Excitation of Electric Oscillations. I'm surprised I haven't looked at this video earlier. This video basically explains how you can, using an electric circuit design, and just frequency, where you can take your swing analogy. So remember, Instead of pushing all the time on my swing, I'm just going to push when the swing gets its height at me, okay? But I'm going to push at a specific frequency. So if I get this thing going fast enough and I'm pushing, instead of it just staying perfectly efficient, it actually gains efficiency. The swing gains efficiency. So let's learn how this works. Now, heads up, the first half of this is heavy in the math, but that's important because it's undebunkable. The math, it shows the proof of the math. So you're going to have to hang tight for the first 10 minutes of this. If the math isn't your thing, I'm probably not going to interrupt. And then when we get to the end, you're going to see the graphs of how it plays out and how it works.
I want to talk today about a lesser-known phenomenon in electricity, the phenomenon of parametric resonance. I came across this effect many years ago in a paper from the 1930s, entitled On the Parametric Excitation of Electrical Oscillations. I only vaguely understood the concept at the time, but years later I was returned to the subject while watching a lecture by Eric Dollard. For those who don't know Eric Dollard, he is an electrical engineer with a background beginning in naval engineering, continuing on as a radio engineer for Bell Labs, and eventually working independently to replicate the work of Nikola Tesla and other scientists of electrical antiquity, and later would devote his life and time to creating books and lectures to elucidate and preserve information on the history of electrical development, the theories which led to these developments, and experiments and effects which have been overlooked or forgotten through time. Eric Dollard still produces lectures and conducts many experiments to this day. It was in his lecture, The Origins of Energy Synthesis, which I had watched tens of times over many years, that something he said struck me that hadn't in all those times before.
Scientists began study of what's called synchronous parameter variation. The meaning of this is the variation of energy storage coefficients, such as inductance or capacitance or resistance, with respect to a point in time on the AC cycle. Now the normally constant or time invariant coefficients change in value with respect to time. Now we have a peculiar set of dimensions of henries per seconds, ohms per seconds, farads per seconds, and Siemens per seconds. And this is where the concept of the law of conservation of energy comes apart, because the energy is appearing and disappearing in these relationships without any equality or connection anymore. Energy can either vanish or energy can appear in the system.
If you don't want to open your third eye, then don't watch this video.
Charles Steinmetz, who Eric is referring to here, writes about this effect in his book, Theory of Alternating Current Phenomena. In this chapter, Steinmetz talks about the parametric variation of inductance naturally taking place in the armature of very large generators. Steinmetz shows that this parametric variation has the effect of either consuming or generating power in the system. The combination of Dollard's lecture in this chapter from Steinmetz's book reminded me of that paper I had read and saved many years before. When I brought up the paper and read it this time, the function of this effect became very clear to me, and I was sure that it was a subject worthy of further investigation. Before we talk about the theory and experimental setup of parametric resonance in electric circuits, I'd like to start with an introduction into mechanical and electric oscillators in their basic form. One of the most simple examples of a mechanical oscillator is a spring and mass system. This equation describes the motion of the mass in terms of the position x. V is the velocity, and a is the acceleration of the mass. These both can be written as the first and second time derivatives of the position, respectively. The displacement x, the mass m, and the spring constant k determine the motion of the mass and spring. B is the damping coefficient, which accounts for the loss of energy due to resistance in the system, such as friction or air drag. For now, we will ignore the losses, so this term can be dropped from the equation. Rewriting this equation, we get the familiar equation F equals ma, where the force F equals negative kx. Rearranging the equation, we arrive at this form. We've already stated that the acceleration is the second time derivative of the displacement. And it turns out that the frequency of oscillation of the system is the square root of the ratio of the spring constant to the mass. Squaring both sides, we can now substitute for A and K over M to arrive at our equation for a simple harmonic oscillator. We can see that the solution of x must be a sine function containing omega t, because its second derivative would be negative omega squared times sine omega t, like we see on the right-hand side. A similar example of a simple harmonic oscillator is the pendulum. The equation is nearly identical, besides the sine term, which is necessary to account for the circular path of the pendulum, and the displacement is in terms of the angle theta instead of the linear position x.
So the reason why the swing analogy works is because you can literally convert this to a pendulum. This is why the swing analogy literally works. It's just an analogy that actually from the equations of the math actually is the same exact kind of thing as a spring. You can just convert it this way.
Here, the motion of the pendulum is determined by the displacement angle theta, the length of the pendulum L, and the gravitational constant g. For small angles, the sine term can be dropped, and again, ignoring the losses, we arrive at this equation. Substituting in a similar fashion, we arrive at a symmetrical equation to the spring and mass system. The most important part to take away is that the oscillation requires two stores of energy to exchange the energy back and forth. Also, note that the frequency of oscillation is related to the ratio of these two energy storage coefficients. Moving to electrical oscillators, we'll look at a circuit with an inductor, capacitor, and resistor in series. By Kirchhoff's law, we write that the voltages across each element must sum to 0. Writing the voltages in terms of the electric charge Q, we reveal three coefficients, L, R, and C. L is called the inductance, which represents the ability to store energy in the magnetic field of the inductor. C is called the capacitance, which represents the ability to store energy in the electrostatic field of the capacitor. And R is called the resistance, which represents the ability to drain the electric energy stored in the circuit by converting the electric energy into mechanical energy as heat, thereby representing the energy loss in the system. The current I, which must be constant through all the elements in the series circuit, is equal to the time derivative of the charge, Q, and so the equation can also be written in terms of I. But for symmetry's sake, we will keep our equation in terms of Q. Ignoring the losses, and dividing by L, we see the relation of the charge Q to its second derivative. The resonant frequency of an inductor and a capacitor in series is given by this equation, and after squaring both sides, we can substitute to arrive at the equation for our electric oscillator.
Okay, for the people who are not good at math, I'm going to give a very quick rundown. We removed the resistance, so we're going to claim for the sake of argument there's no resistance. Let's assume it's superconductive. The capacitor is essentially like equivalent to our battery, so how much capacitance can we hold? And then the inductance, the inductance is the last one. So L, C, and R are the three letters that we have. And the inductance, I don't know, somebody else can help explain the inductance in the chat. But really what we're getting at here now is if we have our circuit, when the electricity is flowing, we're figuring out, okay, we are going to have our capacitor build up potentially with energy. And so this is important that we show all the math here because it's undebunkable. It's mathematically proven. So then the question is, if it's mathematically proven, there's no way to say that this can't work anymore. Now, my guess is what's going to end up happening is people are going to say, well, you got rid of resistance and the system's not perfectly resistant. So there's going to be some inefficiency. And if the inefficiency is high enough, then you're not going to be able to get more energy out than you put into it. But if you were able to get rid of the resistance, the math says we're going to be able to get free energy. Now, wait for it. This is going to pay off. I promise.
It's interesting to note the difference, how the mechanical oscillators are quantified by their spatial displacement from equilibrium, whereas the electrical oscillators are quantified by their electrical displacement from equilibrium, the charge Q. The real-life example of this circuit is a coil of wire, which is good at storing energy in its magnetic field, and a capacitor, which is good at storing energy in its electrostatic field. Here is a more practical example with smaller components.
Oh, what is...
I'm actually paying for the thing, so I think that I'm logged in the wrong account here. Sorry, guys.
Now let's look at a graphical representation of our series resonance circuit. If we charge the capacitor to some voltage with the circuit open, we can see what happens when we close the circuit and the oscillation begins. The energy stored in the electrostatic field transfers into the magnetic field.
Oh, we're definitely getting rid of the resistance. Have you not heard of superconductivity, my friend? So for the record, superconductivity means when the electrons flow with zero resistance. People that think that you can't get rid of the resistance, you're in for a shock, my man. And it's not that we don't even have to. We just have to get it efficient enough. But as you're going to see, you know, any amount of gain is going to increase over time. But this is why Salvatore Pais is talking about superconductivity, because if you do get superconductive where there's no resistance, this thing goes wild.
And at the end of the transfer, all the energy which was stored in the capacitor is now stored in the inductor. Now the energy is returned from the inductor to the capacitor, and all the energy is stored in the electrostatic field once again. This energy exchange continues back and forth forever, since there is no energy lost in the system. Now accounting for the losses, we add a resistor to our circuit. Now we'll see what happens in our resonance circuit when the losses are included. Charging the capacitor and closing the circuit, we can see an exponential decay of the energy in the system.
And so this is what you would expect, because if there's a resistor, you're going to have inefficiency. And so what's going to happen is you're going to have a decay in the efficiency of your system. Now, this is going to be the difference between the classical view that's going to say you can't get rid of the resistance versus a system where if you get rid of the resistance, what's going to end up happening then in this system? And this is where superconductivity becomes so important, is that it's going to make all the difference. And you don't even potentially need it to be superconductive, because as long as your resistance is low enough, then potentially this is going to, the amount of decrease over time is going to shift, right? Also, real quick, Daza MCD. Hey, Ashton, thanks for all your awesome streams. Hal Puthoff is a cool customer. I love this guy. I can't wait to meet him. I don't know how I'm going to make that happen, but we're going to try. Thank you very much for the donation. I appreciate it. Anyway, we're about to get to the good stuff here. I think it's another 5 minutes. Wait. Okay, resistance is futile.
This exponential decay is given by this equation, which is determined by what is called the Q factor of the circuit, which is relational to LC and R, and by the angular frequency of the oscillation omega. With this basic understanding of the series resonance circuit, we are ready to look at the phenomenon of parametric resonance. Here are the equations for the energy stored by the magnetic field, W sub L, and the electrostatic field, W sub C. We will charge our capacitor and let the energy transfer through an initial inductance, which we'll call L negative delta. At the end of the energy transfer, we know that all the energy in the capacitor must now be stored in the inductor. That is, after the transfer, W sub L must equal the initial W sub C. At this moment in the cycle, we increase the inductance of our coil by some means to a greater value L delta, effectively increasing the stored energy, as W sub L is proportional to L. We now allow this greater energy to transfer back into the capacitor. Since W sub C must equal W sub L at the end of the transfer, there will be more energy stored in the capacitor than there was at the beginning of the cycle. Returning L to its original value, we can repeat this process. The now larger W sub C transfers into W sub L, and we again change the inductance to L delta, increasing the stored energy again. The inductor transfers the energy back to the capacitor again, resulting in an even higher W sub C, and the full cycle is complete.
Okay, so if you can't already tell, you can already start to see the magic. Where can you see the magic? Look at the yellow line. Look at the yellow line on the bottom graph. Notice that it starts on this first notch right here. When you look at the yellow line on the right, it's actually higher than the beginning. The yellow line on the right is now higher than where it started to begin with. And the best part about this, there's a lot of people out there that think that free energy is not possible. But anybody that looks at this right now should go, wait a minute, how are we cheating the system right here? This doesn't seem right, right?
We know that L is relational to the frequency of oscillation in the way that when L is lower, the frequency is higher, and when L is higher, the frequency is lower. To make up for this distortion in the sine wave of the oscillation, the inductance must be varied at a frequency relational to the average inductance of L negative delta and L delta. We can also see that the frequency of parameter variation of L must be twice the average resonant frequency of the oscillation. Even though we've used a square wave variation of L for an easier understanding, L may vary sinusoidally and obtain much the same effect, since L is still increased during the discharge of the inductor into the capacitor. Looking at the math of this parametric oscillator, we return to our original equation for the series LCR circuit. Now L varies sinusoidally with an amplitude m. As we saw, omega p is twice the average resonant frequency omega r. Multiplying through by L naught, we can write L naught times m as L delta. Removing the resistance term and multiplying through by Q double dot, we get the equation of a driven oscillator. That is, an oscillator being driven by some source of power. We can see the direct similarity to the equation of a mechanical driven oscillator, where F is the driving force. And looking at the equation for an electrical driven oscillator, where Vd is the driving voltage source, we notice they are identical. Since we know Q double dot is the derivative of current, and we showed that varying L in this way leads to higher current each cycle, the driving force will in turn be greater each cycle, and the oscillations will grow to infinity. Including the losses, we obtain the equation for our parametric oscillator. Here is a real-life example of our parametric oscillators.
So the point that I was just mentioning there, which Will Turner's kind of being a dickhead in the chat, but that's fine, I'll let him slide, is that even with the resistance, you still can obtain this over unity effect that we're about to see here. Now, if you were to remove the resistance, then what's going to happen? Then it's really going to take off. Then potentially you're going to have, I don't know if it's going to be exponential, but probably at least linear growth. And every time you go through a cycle. And what is a cycle? That's going to be our frequency. So, and what he's about to show here, and maybe I'm saying that wrong, because what he's about to show here is that there's a specific level where you achieve certain frequency. Again, I'm not classically trained, where it will work, and anything under a certain level doesn't work, basically. And this is where you get to this idea of there may be specific frequencies that allow for this type of parametric oscillation to take off versus other frequencies where it's not going to work. But here we go.
Circuit. We have our variable inductor, delta L, and a capacitor bank, C. The way the variable inductor works is by passing a toothed disc of copper between pairs of series-connected coils. When the copper is in between the coils, the inductance is lower. And when there is just air between the coils, the inductance is higher. As the disc spins, the inductance will vary sinusoidally.
Okay, so based on what he just showed, the inductance, when he's talking about manipulating the inductance, he's talking about the top. We were just looking at those graphs. The top graph was our inductance. And that's why he's saying we can make this to be sinusoidal. And there he's going. He's showing how do you engineer that? Well, in this case, he took a copper plate with little bars on it, and he's got it spinning through his electromagnets there. And that's changing the inductance factor. Correct me if I'm wrong on that, chat. And somebody we're going to read the comments in a minute. Somebody in the comments points out that it's better to use iron than a copper plate or whatever that he's using there. But here we go. Yeah, sorry guys. I'm going to fix the ad thing. It's because I'm logged in the wrong account. Here we go. It's payoff time, guys. Get ready. Here we go. Look at what's happening on the bottom, chat. Look at what's happening. Look at our yellow line, chat. Oh, crap. I have it muted. Hold on. We're going to watch that part again anyway. So basically, this bottom right down here is the bottom right here is his mechanical setup while the wheel's spinning. And you're seeing the growth. You're seeing the energy increase here.
Some latent charge. The process of exponential growth begins, and after a short amount of time, the current begins to take off. And since the current must be constant through all the elements, we see that the voltage across the resistor takes off as well. This means that real power is being generated in the system, and is able to do real work, creating heat through the resistor. Seeing on the right the equation for the energy gained per cycle by the change in inductance, and the equation for the energy lost per cycle through the resistance, the condition where the oscillations go to infinity is given by this inequality. That is, the energy gained due to the change in inductance per cycle must be greater than the energy lost to the resistance per cycle. Looking closer at the inequality, we can simplify by dividing each side by a half.
And this is really logical. The energy gained per cycle needs to be greater than the energy lost per cycle, right? I mean, that's just simple understanding. As long as I'm getting more energy per cycle than I'm losing, what's going to happen? The energy is just going to skyrocket. Simple as that. So here you go. This is how you can use oscillation to increase your energy exponentially. And then what if our resistance is zero? What if now we have a superconductor with zero resistance? Then what happens? Then literally no matter what the inductance is, you're going to have an exponential increase in energy. How do we get enough energy to teleport an airplane? Boom.
Half and by I squared, to get the very simple relation delta L greater than RT, where T is equal to the time of a quarter period. Using the values from the previous example, we get a resonant frequency of about 1027 Hz, which gives a period of nearly 1 millisecond. Dividing by 4 gives T, the time interval of energy exchange. Finally, plugging in and solving for R, we get about 165 ohms. Starting with a resistance above 165 ohms, we can see that the oscillation exponentially decays as more energy is lost than gained per cycle. As we drop the resistance below 165 ohms, the oscillation grows exponentially as more energy is gained than is lost per cycle.
So there you go. If you have a resistance above 165 in this particular scenario, then you're going to have the exponential decrease. This graph explains exactly how we can get free energy. If our resistance is too high, then we're going to lose energy every cycle, and it's going to decrease exponentially. If our resistance is low enough, goes below the threshold, and the more it goes down below the threshold, the more these bands, the quicker they increase exponentially. So when you reduce that thing to zero, now your energy is just through the roof. And it doesn't even have to be zero, but the lower it gets, the crazier this graph gets that we're looking at right here.
And as we hone in on 165 ohms, we see the tipping point for the condition of parametric resonance to occur. Thank you all for watching, and thank you to this year's Summer of Math Exposition for inspiring me to make this video.
Absolutely wild. I'm going to show the last little bit right here one more time because it's so huge. I mean, this is the answer right here. How do you get free energy? I just taught you guys how to get free energy. It's really that simple. Do you still not think a magnetic motor can produce free energy? Look at what we're looking at in the bottom right corner over here. Look at what that wheel looks like. Look at that little wheel right there with the inductance. Do you guys understand how a magnetic motor is possible now? Looks just like the wheel on a magnetic motor, doesn't it? Doesn't it?
As even any dead capacitor will have some latent charge. The process of exponential growth begins, and after a short amount of time, the current begins to take off. And since the current must be constant through all the elements, we see that the voltage across the resistor takes off as well. This means that real power is being generated in the system and is able to do real work, creating heat through the resistor. Seeing on the right the equation for the energy gained per cycle by the change in inductance.
Yeah, I think maybe this is like the double bounce example. Is it? Probably. I'm not sure, actually. Honestly, I'm not smart enough yet, guys. Like, truthfully, I've never claimed to be like electrical engineering is the thing I struggle with the most. I'm much better at the physics and the theoretical physics than I am the engineering, but you have to know both. You just have to know both. They're just coupled in a way because the universe is electric, you can't fully understand physics without understanding electrical engineering. And this is the part where I have to study more. Truthfully, I'm not going to be on the level of electrical engineering that I am on physics for probably another year or so. Maybe a little bit longer. I don't know. I've been a fast learner. I've even surprised myself. But yeah, the eddy currents are what is going to stop this and slow this down. However, if you use iron instead of copper, then apparently it solves eddy currents. We're going to read some comments as well because I love when I see videos like this that are mind-blowing. I immediately want to go in the comments because you know there's going to be some smart-ass people in the comments.
And the equation for the energy lost per cycle through the resistance, the condition where the oscillations go to infinity is given by this inequality. That is, the energy gained due to the change in inductance per cycle must be greater than the energy lost to the resistance per cycle. Looking closer at the inequality, we can simplify by dividing each side by a half and by I squared to get the very simple relation delta L greater than RT, where T is equal to the time of a quarter period. Using the values from the previous example, we get a resonant frequency of about 1027 Hz, which gives a period of nearly 1 millisecond. Dividing by 4 gives T, the time interval of energy exchange. Finally, plugging in and solving for R, we get about 165 ohms. Starting with a resistance above 165 ohms, we can see that the oscillation exponentially decays as more energy is lost than gained per cycle. As we drop the resistance below 165 ohms, the oscillation grows exponentially as more energy is gained than is lost per cycle. And as we hone in on 165 ohms, we see the tipping point for the condition of parametric resonance to occur.
So that's pretty awesome, guys. I mean, holy shit. I just showed you guys the secret sauce, right? I mean, now it's just a matter of engineering, it. Now we've seen the equations, we've seen the concepts, we can understand the concepts. Now our swing starts small and it this is mind-breaking stuff. I'm going to answer one question on the free energy stuff. There's stuff happening behind the scenes, but I have stepped back a little bit from it. Again, not because it doesn't work, but because it does work and because I don't want to be killed. That's mainly the strongest reason. I'm just keeping it 100 with you guys. But as you can see here, like this science is just out there. It's been out there. So then the question is, why have people not done it? Or have they? Or have they done it? And the reality is I don't need to be the guy that's the Elon Musk of free energy. I don't really care about that. I'm happy enough to be in a position where when people can accept it, that, all of a sudden I'll be, a billionaire from people wanting to throw their money at people who figured this out and have a working product, right? But truthfully, like free energy is pretty cool. I'm not going to lie. I think it's probably one of the coolest aspects of all of this in the investigation. But I don't know. I kind of like the gravity manipulation stuff a little bit better. I don't know. Anyway, I like all of it. Okay, so the next thing that I wanted to show. Oh, let's go. I wanted to go do the comments. Where is this? I want to read a few of the comments. Yeah, I'm logged in on the wrong account. So sorry for the people that we had the commercials. That was my bad entirely. My thing logged into my wrong account. That's why, because I pay for no commercials for you guys. So apologies on that. And yeah, once again, like I didn't know shit I knew nothing about electrical engineering less than 1 year ago. Literally nothing at all. So, this has been a journey for me as well. And most people have like 2 to 8 years of experience on this, right? So here we go. And honestly, this video here is probably pushing the absolute limit on what I feel comfortable sharing with people. It really is. But if anything happens, now you have the secret sauce. This guy had a thing that you can engineer. You can probably figure out how magnetic motor can work based on this pretty easily. So I gave you guys more than enough. I've shown videos as well where there's coefficient of performance greater than 1, which shouldn't be that hard to understand now that you've seen this, because you've seen the equations. So resistance does not store energy. Okay, well, skip that part. I'm amazed to see other people following it. Someone noticed that replacing the copper wheel with an iron wheel would solve the eddy current problem. That's interesting. There's my comment that I added a couple hours ago. You can find in CIA FOIA requests, you can find a paper from 1951 on parametric power generation, which does in fact seem to be an over unity device using the exact same concept. Can somebody find this in our Discord? I want somebody to find the CIA FOIA request paper on parametric power generation from 1951. I'm going to make a note in my thing here. 1951 CIA FOIA parametric power. I want to find that, chat. Pretty sweet. Yeah, now people are talking about Coral Castle and all this other stuff, because honestly, like, once your mind opens up to this, you're like, whoa, what is all possible? I don't want you guys to go completely crazy with this, but there you go. Let's see. Eric Dollar, harmonic oscillations and coil windings generate parametric dielectric energy storage coefficients, farads per second. Good path to follow. Tesla coils. The graphics are great. Yes. I'm trying to think of... I thought I saw some other good comments down here. But you can see that the limitation here for a lot of people is just it's too complicated to understand, because most people don't really understand electrical engineering. But if you do understand electrical engineering, then bingo, chat. Bingo. I'm not going to FOIA the 23-minute video. I just don't care. They're never going to give us a 23-minute video. But if somebody gets given it, there you go. Oh, somebody already found this. Can somebody post a link to this somewhere where I can post it in our Discord? I appreciate that. Let's see. Oh, and then somebody says you have to demonstrate it, right? Well, this part 2 is the part where it's, well, the math shows that it works, right? The math shows that it works and that it can work. And this person replied, which is interesting. You don't even need capacitors. That's the secret. Huh. That's pretty wild. I don't know exactly what that means, but it feels like there's something to this. So that's another interesting, cool thing. Changing the inductance is like if you magically could change the spring harder when the mass is dropped, or make the mass heavier when the pendulum is at its highest point. Just trying to get the idea. That's exactly right. So this is like basically saying that not only are we able to push the swing at the right time, but we can manipulate it so that we're somehow pushing harder when the swing gets to its perfect point. And of course, if you push the swing harder every time, it's gonna get bigger and bigger and bigger and bigger and bigger. So manipulating the inductance seems to be a key here. Actually, I think I've read enough. I'm feeling like we're pushing it way too far here. This person says you can't do it. And then the response is that the energy used to spin the disc to charge the inductance is not transferred to the rest of the system. No transduction. That law isn't even real in the first place, but a result of poor understanding and bad engineering. So this here is issue 2, where a lot of people who are engineers don't even understand the concepts themselves. And this is what leads to a situation where people don't understand how over unity is possible. I'm not going to read all of that. It's all there. I've got a link to this in the chat or in the description so you guys can check it out. I've given it to you guys. I've given you the knowledge on free energy. The last thing we're going to look at tonight is, then I asked the same person that created the AI model. I asked them to ask how parametric oscillation plays into it. So I'm going to read some of this as well. To address the parametric resonance, are we okay? You guys can see my screen. To address the parametric magnetic resonance of electric oscillations in the context of plasma, we delve into the magnetic, electric, and plasma inductions. Let's see. Sorry. Oh, okay, here we go. In paramagnetic resonance, we're dealing with materials that have unpaired electrons. These electrons give the material a magnetic moment that can align with the external magnetic field, but these magnetic moments are relatively weak compared to the ferromagnetic materials. In the context of plasma physics, the resonance becomes significant when the paramagnetic material is subjected to oscillating electric fields, which create magnetic dipole moments that can oscillate at a particular resonant frequency. One sec. I'm not sure if this is what I wanted, actually. The susceptibility of a paramagnetic, I think I wanted parametric and not paramagnetic, so maybe I have to ask again. But anyway, it says the susceptibility of paramagnetic material to external fields affects how much of its magnetic dipoles can align and interact with the electric and magnetic fields in the plasma. The resonant interaction can enhance or reduce the plasma's local magnetic fields. Let me just go to I'm just going to read the conclusion. There's too much here. In conclusion, paramagnetic resonance of electric oscillations in plasma represents a complex, powerful interaction between magnetic dipoles and the electromagnetic fields. By matching the oscillation frequencies to the Larmor precession frequency of paramagnetic materials, we can optimize energy transfer, enhance plasma stability, and control plasma behaviors in various applications, from fusion reactors to space propulsion systems. The equations and formulas we presented allow us to model these interactions in detail, guiding future experimental and theoretical work in this area. Now, why is this huge? Because this is the idea that we can create our plasma orb utilizing parametric and paramagnetic resonance in electrical and electromagnetic systems. Pretty amazing. Now, let's take a look at the next thing. I think there's like one more paragraph, guys, and then we're good for tonight. Yeah, I think I asked the wrong question. I'm going to probably have it asked another question, and we'll talk about it later. It actually talks about the plasma sheath here as well. So the magnetic effect can change the plasma sheath, which is exactly what we see with the orbs. So there's definitely some oscillations happening from the electric circuit that's being created through the plasma orbs in the MH370 videos. With additional equations, theories, formulas, we expand our understanding of paramagnetic resonance in plasma systems and explore new ways to harness these effects for plasma confinement, energy transfer, and magnetic field control. The combination of resonance effects, magnetic gradients, and feedback loops opens up new possibilities for fusion energy research, plasma processing, and even space propulsion. These advances create a pathway toward more efficient plasma systems and may one day be integral in the development of next generation energy sources or advanced propulsion technologies. So why is this important, guys? Well, you know why. This is why. This right here is why. Now we know what we're seeing, right? We're seeing plasma oscillations that are able to increase the energy levels exponentially. We're increasing the energy exponentially to a point where we have as much energy as we need. To break the Schwinger limit's just trivial at that point. And now you can see why they hide this as well, is that any situation where we can manipulate plasma to create exponential energy growth, of course you can make a black hole. Of course you can. Anytime where you have exponential energy growth, you take it to its absolute limit. Again, like the magic card scenario, is that how can you break this? Well, anytime you're dealing with exponential energy growth, a wormhole is basically just getting to the point where we can break the Schwinger limit, where space becomes nonlinear. And then, yes, potentially have our entangled fourth orb. And then wherever this is, it's going to shoot out to some other location. And then if we scale that up even more, Why can't we make and change the charge polarity potentially? So instead of negative energy, we make a very positive energy. So again, with our Dirac C, we can do negative energy like we see with that video that we just saw. We can make a wormhole, or we can do this. We can add energy. And if we can add energy, then we can create a gravitational force equivalent to the strength of a black hole. Make a real black hole. And end the solar system if you want, guys. You can end the entire solar system. Hey, maybe end the universe. We might be able to make our own Big Bang. So this is why I think it's important to discuss these concepts, because we need to understand the implications. So for the people that are watching that are like, well, Ashton's going to get killed today. First of all, I have no regrets. Second of all, I think it's very important because this can't be hidden forever. This cannot be hidden forever. So we need to be able to address this and understand the risks and try to understand ways where we can limit ourselves from blowing up the whole planet. Find a way to stop from destroying ourselves. This is not nuclear weapons, guys. This is infinitely more powerful than nuclear weapons. And that's why it's dangerous. Because with nuclear weapons, you can prevent people from getting uranium. You can sabotage them. You can stop them before they've built the weapons. With this, it's potential where like somebody in their garage who figures this out can destroy us all. Just one person with the push of a button. Very dangerous. So there you guys go. So anyway, I hope you guys have a great weekend. We will have another stream on Monday. We'll go over more Malaysian Airlines Monday stuff. Check out the other streams. Check out my content. I'm going to go through and start pushing stuff onto Obsidian this weekend, moving a lot of the data to a better readable form that's more easily shared. And yeah, we'll be in touch soon, guys. Love you guys. I'm H370X. Peace out.
In the fields where the skies are wide, talking about a journey through the cosmic ride. Einstein and Thorne, they set the stage for a trip through time across the space age. Wormholes connect distant points in space, traversable paths to a far off place. No black holes pull, no crushing weight, just a cosmic tunnel to a distant gate.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow.
Exotic matter, negative energy's the key to stabilize the wormhole for you and me. Quantum vacuum squeezed so tight, creating conditions for this wondrous flight. Static fields and lasers in the lab they play, generating forces in a new kind of way. Gravitational squeezing, Casimir's force, negative zones we need to stay the course.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow.
Thin shell formalism plates so fine, spherical geometry we realign. Energy conditions that we must defy. For a stable wormhole, let's give it a try. Forces balancing the plates, creating the throat, open the gates, from Earth to the stars in a single bound, a shortcut through space profound. Engineers and dreamers hold the key to future worlds and what we could be. With science in hand, we forge ahead through the cosmic paths that we now tread.
We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go?
flow. From the fields to the stars, we break the chains. Understanding the universe, we make the gains. Lil Hula Crunk shines, bringing truth to light. Through his music, we'll explore the night. With wormholes and stargates, our path is clear. Exploring the cosmos, our future.